Good morning. In our last class, we were discussing MCQs on electric potential, and we'll continue some of the other MCQs, some of important other MCQs on electric potential as well in this class. And from tomorrow, we'll start the chapter atoms. We'll continue capacitance once you come back to the college. Here are some of the other important type of MCQs that you must solve for electric potential. See, in the last class, I have told you work done in carrying a charge from one point to another point in an electric field is independent of the path followed by the particle or path followed by the charged particle. ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟಿಗೆ ಚಾರ್ಜ್ ನ ತಗೊಂಡು ಹೋಗ್ಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಆಗ್ತದೆ ಅನ್ನೋದು ಇಟ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಪಾತ್ ಫಾಲೋಡ್ ಬೈ ದ ಪಾರ್ಟಿಕಲ್ ವಾಟ್ ಎವರ್ ಮೇ ಬಿ ದ ಪಾತ್ ಫಾಲೋಡ್ ಬೈ ದ ಪಾರ್ಟಿಕಲ್ if the initial and the final positions of the charged particle are the same, work done will be same along all the possible paths. Whatever may be the path followed, if initial and the final positions are the same, then the work done will be same along all the paths. I have told you how to calculate work done in carrying a charge from one point to another point. Work done in carrying charge from one point to another point is given by potential difference into charge. ಎ ಇಂದ ಬಿ ಒಂದು ಚಾರ್ಜ್ ನ ಮೂವ್ ಮಾಡಿರಿ ಅಂತಂದ್ರೆ ಎ ಹತ್ರ ಪೊಟೆನ್ಶಿಯಲ್ ಎಷ್ಟದೇ ಗೊತ್ತಿರಬೇಕು, ಪಾಯಿಂಟ್ ಬಿ ಹತ್ರ ಪೊಟೆನ್ಶಿಯಲ್ ಎಷ್ಟದೇ ಗೊತ್ತಿರಬೇಕು. ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಎ ಅಂಡ್ ಬಿ ಇಸ್ ಟು ಬಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಂಟು ದ ಚಾರ್ಜ್ ಮೂವ್ ಬಿಟ್ವೀನ್ ದೋಸ್ ಟು ಪಾಯಿಂಟ್ಸ್. ಎ ಇಂದ ಬಿ ಯಾವ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ದಟ್ ಗಿವ್ಸ್ ಅಸ್ ದ ವರ್ಕ್ ಡನ್. ಹಿಯರ್ ಇಸ್ ಎ ಪ್ರಾಬ್ಲಮ್ ಆನ್ ಇಟ್. ಎ charge plus q, a charge plus q is placed at origin O of xy axis as shown in the figure. Work done in taking charge capital Q. Work done in taking charge capital Q from A to B along straight line AB is. See, this is the diagram shown. A charge Q is placed at origin O of xy axis. You need to calculate work done in carrying charge capital Q. You need to calculate work done in carrying this charge capital Q from point A to B along the straight line AB. A ಇಂದ B ಗೆ ಈ ಚಾರ್ಜ್ ಕ್ಯಾಪಿಟಲ್ Q ನ ತಗೊಂಡು ಹೋಗ್ಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಆಗ್ತದೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. See, we can calculate work done in carrying charge between any 2 points if we know the potential difference between those 2 points. We must be knowing what is potential at A. We must be knowing what is potential at B. Then we can calculate potential difference between B and A. And if we multiply potential difference by the charge moved is capital Q, we'll get the work done, right? So work done in moving charge from one point to another point is given by potential difference into charge. Potential difference is VB minus VA. See, final position of the charge is B. Initial position of the charge was A. Potential at final position minus potential at initial position gives us potential difference. VB minus VA into the charge moved is capital Q. Charge moved is capital Q, right? Now, in order to calculate potential difference, we must be knowing what is potential at A and we must be knowing what is potential at B. See, potential at A is produced by this source charge Q. Potential at B is also produced by this source charge Q. This source charge small q another. This is going to produce potential at A and the same source charge is going to produce potential at B. We know that potential at a point due to a source charge is given by V is equals to 1 by 4 pi epsilon Q by R, where R is the distance between source charge and the point. Now, can we calculate potential at this point A? And yes, that can be done. Potential at A is VA is equals to 1 by 4 pi epsilon naught Q divided by, see, the position coordinates of A is, position coordinates of A are A comma 0. And the point A is at a distance A from the origin. So potential at A is 1 by 4 pi epsilon naught Q by A. Similarly, you can calculate potential at point B due to source charge small q. Potential at B due to Q is 1 by 4 pi epsilon naught Q divided by, see, the distance of B is small b. Distance of point B is small b. Coordinates of B is 0 comma B. Hagadre from the source charge small q, point B will be at a distance small b. So potential at B is 1 by 4 pi epsilon naught Q by B. So we got to know what is potential at B. We got to know what is potential at A. So potential difference can be calculated. VB minus VA is 1 by 4 pi epsilon naught Q by B minus 1 by 4 pi epsilon naught Q by A. VA is 1 by 4 pi epsilon naught Q by A. Into charge mode is capital Q. Now the common factor among these two is in this term and in this term. The common factors are 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught will be the common factor among these two terms. Also Q will be the common factor. Q kuda common annodri iveradukku. Hagadre we can take Q by 4 pi epsilon naught as common. We will be left out with 1 by B minus 1 by A. 1 by B minus 1 by A into ಈ ಚಾರ್ಜ್ ಇರ್ತದಲ್ಲ ಇದನ್ನ ಹಾಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು Q. So Q into capital Q divided by 4 pi epsilon naught. LCM ಮಾಡಿದ್ರೆ AB ಆಗ್ತದೆ. This A is to be cross multiplied here, B is to be cross multiplied here. So A minus B divided by A into B. Can you tell me what are this A and B? A, B, A now. What are A and B? Tell me what are A and B. Small q is source charge. See, small q is source charge. Capital Q is charge that has to be moved from capital A to capital B. Tell me what are A and B. Small a, small b ಏನು ಹೇಳ್ತೀರಾ? Can you tell me what are small a and small b? Small a ಮತ್ತೆ small b ಏನು? Very good. They are distances. Small a and small b are the distances of point A and point B from the origin. Origin in the point A, the distance small a ade. Origin in the point B, the distance small b ade. So small a and small b are the distances of the points from the source charge. Source charge in the given points ಎಷ್ಟು distance nagave ಅನ್ನೋದು A ಮತ್ತೆ B. ಹಾಗಾದ್ರೆ tell me what ಹಾಗಾದ್ರೆ now the work done is calculated. Work done in carrying a charge capital Q from point A to B is Q small q divided by 4 pi epsilon naught A minus B divided by A into B. So the option will be A. Small q capital Q divided by 4 pi epsilon naught A minus B divided by A into B. Can you tell me what will be the work done if the 2 points A and B are at equal distance from the source charge? What will be the work done if points A and B are at equal distance from the source charge? Source charge in the point A and point B equal distance nagidre, can you tell me what will be the work done in carrying charge from one point to another point? Very good. 0 ಆಗ್ತದೆ. A ಮತ್ತೆ B the distance equal ಆದ್ರೆ A 10 cm ಇದ್ರೆ B ಕೂಡ 10 cm ಇರ್ತದೆ. 10 minus 10 will be 0. 0 into anything will be 0. ಇದು ಒಂದು. If the distance of the point from the source charge are the same, if distance of the point from the source charge are the same, if you just substitute that in this equation, potential work done becomes 0. ಇದು ಒಂದು ಆದ್ರೆ you can also use this formula for finding out work done. If both the points are at equal distance from the source charge in the ಎರಡು ಪಾಯಿಂಟ್ಸ್ equal distance ನಾಗಿದ್ರೆ ಪಾಯಿಂಟ್ A ಹತ್ರ ಎಷ್ಟು ಪೊಟೆನ್ಷಿಯಲ್ ಇರ್ತದೋ ಪಾಯಿಂಟ್ B ಹತ್ರನೂ ಅಷ್ಟೇ ಪೊಟೆನ್ಷಿಯಲ್ ಇರ್ತದೆ. At point A, electric potential is V is equals to or VA is equals to 1 by 4 pi epsilon naught Q by A. At point B, potential will be VB is equals to 1 by 4 pi epsilon naught Q by A again. A and B are at same distance A anta ತಗೊಳ್ರಿ. ಹಾಗಾದ್ರೆ potential at A and potential at B will become equal. ಹಾಗಾದ್ರೆ potential difference between A and B will be 0. Potential difference 0 ಇತ್ತು ಅಂತಂದ್ರೆ work done to move the charge from one point to another point will be 0. Right? So if 2 points are at equal potentials, then work done in moving a charge from one point to another point will be 0. Do you remember what is that surface over which electric potential will be same at each and every point called as? A surface of constant potential. What is that surface called as? A surface of constant potential. A surface of constant potential. It is called as an equipotential surface. Equipotential surface ಮೇಲೆ ಕೂಡ ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ವರ್ಕ್ ಡನ್ 0 ಇರ್ತದೆ. Because there will be no potential difference between the 2 points on that surface. So remember this problem. So in order to move charge from one point to another point, work done will be small q capital Q divided by 4 pi epsilon naught A minus B divided by A into B. if A and B are equal, if distance of point A and distance of point B are equal, then work done to move the charge from A to B will become 0. Adhu nanu ಇಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡೀನಿ. ಇಲ್ಲಿ ನೋಡ್ರಿ ನೋಟ್ ಒಳಗೆ I have done it. If points are at equal distance from the source charge, then potentials at those points will be equal. Therefore potential difference becomes 0. ಎರಡು ಪಾಯಿಂಟ್ಸ್ equal distance ನಾಗವೆ ಅಂತಂದ್ರೆ point A is a distance r, point B is also a distance r ಅಂತಂದ್ರೆ source charge ಇಂದ point A ಹತ್ರ ಎಷ್ಟು potential ಇರ್ತದೋ source charge ಇಂದ point B ಹತ್ರನೂ ಅಷ್ಟೇ potential ಇರ್ತದೆ. So work done in moving charge between those 2 points will be 0. If the 2 points are at equal distance from the source charge, then potentials at those 2 points will be equal, and so potential difference will be 0. Illi torsi nodri, I have represented it here. This is source charge, this is point A. Point A is at a distance A from the source charge. Point A the distance ಎಷ್ಟು ನೋಡ್ರಿ source charge ಇಂದ A ಅದೇ. Point B is at a distance A from the source charge again. ಅಂದ್ರೆ point A as well as point B are at distances A and A from the source charge. Coordinates of point A is A, 0. Coordinates of point B is 0, A. If you have to write the potential at point A due to source charge, it will be VA is equals to 1 by 4 pi epsilon Q by A. Potential at point B due to this source charge, VB is equals to 1 by 4 pi epsilon Q by A. If we calculate potential difference between these 2 points, A and B madhya potential difference madidre, VB minus VA, VB is 1 by 4 pi epsilon Q by A, VA is also 1 by 4 pi epsilon Q by A, so potential difference between those 2 points will be 0. If potential difference between 2 points is 0, what will be the work done? Work done is potential difference into charge. Potential difference 0 ಆಯ್ತು ಅಂತಂದ್ರೆ 0 into anything will be 0. So work done in moving charge between 2 points which are at equal distance from the source charge will be 0. Why we have taken VB minus VA, why not VA minus VB ಅಂತಂದ್ರೆ, see potential difference must always be calculated between final position and the initial position. Potential difference must be calculated between final position and the initial position. Potential difference must be calculated between final position and initial position. Right? ಇಲ್ಲಿ ನಮಗೆ ಚಾರ್ಜ್ ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಮೂವ್ ಮಾಡ್ಬೇಕಂತ ಹೇಳ್ಯಾರ ನೋಡ್ರಿ. See from where to where the charge is to be moved. ಈ ಪ್ರಾಬ್ಲಮ್ ನಾಗೆ we are asked to move the charge from A to B. We are asked to calculate work done in taking the charge from A to B. So B will become the final position, A will become the initial position. So potential difference ಮಾಡಬೇಕಾದ್ರೆ VB minus VA ಮಾಡಬೇಕು. 1 by 4 pi epsilon Q by B minus 1 by 4 pi epsilon Q by A ಬರ್ತದೆ. Suppose you are asked to find work done in moving the charge from B to A. If you are asked to calculate the work done in moving the charge from B to A, tell me which option would come out to be true among these 4. Which option would come out to be true if you are asked to calculate work done in carrying charge capital Q from B to A? B to A ಹೇಳಿದ್ರೆ ಯಾವ ಆಪ್ಷನ್ ಕರೆಕ್ಟ್ ಆಗ್ತಿತ್ತು? ಆಪ್ಷನ್ B would be right there. VA minus VB ಮಾಡಬೇಕಾಗಿತ್ತು. If you are asked to calculate work done in carrying charge from B to A, B to A ಕೇಳಿದ್ರೆ, if the charge had to be moved from B to A, you would be calculating potential difference as VA minus VB. Final potential minus initial potential ಮಾಡಬೇಕು. ಯಾವಾಗಲೂ potential difference calculate ಮಾಡಬೇಕಾದ್ರೆ you should always do final potential minus initial potential. Am I clear? Am I clear with this point? Why I have taken VB minus VA? Why I have taken VB minus VA is clear. ಯಾವಾಗ VA minus VB ತಗೋಬೇಕು, ಯಾವಾಗ VB minus VA ತಗೋಬೇಕು, ಕ್ಲಿಯರ್ ಇರಬೇಕು. Final potential minus initial potential. So this is regarding problem on calculating work done to carry charge from one point to another point. ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ಗೆ ತಗೊಂಡು ಹೋಗ್ಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಆಗ್ತದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಅಂದ್ರೆ, ಯಾವ ಪಾಯಿಂಟ್ ಇಂದ ಯಾವ ಪಾಯಿಂಟಿಗೆ ಚಾರ್ಜ್ ತಗೊಂಡು ಹೋಗ್ಬೇಕು ನೋಡ್ಬೇಕು. ಎ ಇಂದ ಬಿ ತಗೊಂಡು ಹೋಗ್ಬೇಕು. A hatra potential ಗೊತ್ತಿರಬೇಕು, B hatra potential ಗೊತ್ತಿರಬೇಕು. See, I have calculated potential at A, also I have calculated potential at B. Then I can calculate work done as potential difference into charge, VB minus VA into Q. So if you are asked to calculate work done to carry charge from one point to another point, calculate the potentials at those 2 points, then calculate potential difference between them, multiply the charge that is to be carried. Potential difference is charge multiply madri, you will get the work done, right? Idadmele, there may also be problems on calculation of kinetic energy. I have told you, using work energy theorem, you can write this work done as change in kinetic energy. ನೀವು ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಿರ್ತೀರೋ ಆ ಚಾರ್ಜ್ ಅಷ್ಟು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಚೇಂಜ್ ಆಗಿರ್ತದೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್, ದ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ will always be equal to change in kinetic energy of the particle. If you have done this amount of work, this will be the amount of change in kinetic energy of the particle. 10 joules work ಮಾಡಿದ್ರೆ change in kinetic energy of the particle will also be 10 joules. ಅದ್ರ ಮೇಲೆ ಕೂಡ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ನೋಡ್ರಿ. An electron of mass m kg and charge E travels from rest. This is important. An electron of mass m kg and charge E travels from rest through a potential difference of V volts. Remember, ಎಲ್ಲೆಲ್ಲಿ ನಿಮಗೆ ಚಾರ್ಜ್ ಮತ್ತೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬರ್ತದೋ ಅಲ್ಲೆಲ್ಲ ವರ್ಕ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡ್ರಿ, ಎಲ್ಲೆಲ್ಲಿ ಚಾರ್ಜ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬರ್ತದಲ್ಲ ಅಲ್ಲೆಲ್ಲ ಫಸ್ಟ್ ಕೆಲಸ ನಾವು ವರ್ಕ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಬಿಕಾಸ್ work done is equals to potential difference into charge. Because work done is equals to potential difference into charge. ಎಲ್ಲೆಲ್ಲಿ ಚಾರ್ಜ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬಂತು ಅಲ್ಲೆಲ್ಲ ವರ್ಕ್ ಡನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ವರ್ಕ್ ಡನ್ ಗೊತ್ತಿದ್ರೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಗೊತ್ತಿರ್ತದೆ. ವರ್ಕ್ ಡನ್ ಗೊತ್ತಿದ್ರೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಗೊತ್ತಿರ್ತದೆ. half mv² will be known, right? So with this understanding, ಇಲ್ಲಿ ನೋಡ್ರಿ ಏನದೆ, an electron of mass m kg and charge E travels from rest through a potential difference of V volts. Find the final velocity of the electron. Initially, the electron is at rest. This electron will travel through a potential difference V volt. There are 2 points A and B. The potential difference between 2 points is given as V volts. Electron will move or electron will travel through this potential difference. Here points madhye travel ಆಗ್ತದೆ electron. If the electron is traveling, it must be acquiring some kinetic energy. Actually, the electron was initially at rest. Or here nodri, electron travels from rest anta helare. Andre the electron was initially at rest. It now starts moving in a potential difference V volts. You have to calculate what is the final velocity of the electron. Initial velocity of the electron is already given to us. Initial velocity of the electron is 0. Andre the initial kinetic energy estirbeku. Initial velocity of the charged particle, initial velocity of electron is 0. Can you tell me what should be its initial kinetic energy? What should be its initial kinetic energy? Initially, electron is at rest. What should be its initial kinetic energy? Initially, one electron rest nagade. Adradu kinetic energy estirtade heltira? Its initial kinetic energy should be 0. Initial kinetic energy should be 0. Right? Iga ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತದೆ ಅಂತಂದ್ರೆ ಈ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ನ ಟ್ರಾವೆಲ್ ಆಗ್ತದೆ. ಎಲೆಕ್ಟ್ರಾನ್ ಟ್ರಾವೆಲ್ಸ್ ಥ್ರೂ ಎ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಆಫ್ V volts. When electron travels through a potential difference of V volts, it should acquire some energy. ಮೂವ್ ಆಗ್ತಿರೋದಂದ್ರೆ it should acquire kinetic energy. Kinetic energy ಮುಂಚೆ 0 ಇತ್ತು, ಈಗ ಮೂವ್ ಆಗ್ತಿರೋದ್ರಿಂದ ಅದಕ್ಕೆ ಒಂದು ಸ್ವಲ್ಪ kinetic energy ಬಂದಿರಬೇಕು. ಅಂದ್ರೆ 0 ಇಂದ 10 joule 20 joule ಆಗಿರಬೇಕು. There must be a change in its kinetic energy. How do you find change in kinetic energy ಅಂತಂದ್ರೆ that can be done using work energy theorem. ನಮಗೆ actually kinetic energy ಕೇಳಿಲ್ಲ. Instead we are asked final velocity. Final velocity we will calculate it. ಹೇಗೆ ಮಾಡಬೇಕು ನೋಡ್ರಿ. When we know potential difference and charge, we can always calculate work done. From work energy theorem, work done is equals to change in kinetic energy. Remember this work energy theorem. This will help you in many number of problems. ಎಲ್ಲೆಲ್ಲಿ ಎನರ್ಜಿ ಕೇಳಿರ್ತಾರೋ ಅಲ್ಲಿ ನಮಗೆ ಕಾಮನ್ ಆಗಿ ವರ್ಕ್ ಡನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತಿರ್ತದೆ. ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಸರ್ಚ್ ಫಾರ್ ಪ್ರಾಪರ್ ಡಾಟಾ. ಎಲ್ಲಿ ಎನರ್ಜಿ ಕೇಳಿರ್ತಾರೋ ಅಲ್ಲಿ ಡೆಫಿನೆಟ್ಲಿ ವರ್ಕ್ ಡನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಡಾಟಾ ಕೊಟ್ಟಿರ್ತಾರೆ. ವರ್ಕ್ ಡನ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಚೇಂಜ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅಕಾರ್ಡಿಂಗ್ ಟು ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್. ಸೊ ವರ್ಕ್ ಡನ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಂಟು ಚಾರ್ಜ್. ವರ್ಕ್ ಡನ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಚೇಂಜ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ದಟ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಸಿ ಎಲೆಕ್ಟ್ರಾನ್ ಆರ್ ಚಾರ್ಜ್ E travels from rest through a potential difference of V volts. Charge is given as E and potential difference is given as V volts. So potential difference is V volts and charge is E. So kinetic energy is equals to EVI. Kinetic energy is equals to E into V. ನಮಗೆ ಕೇಳಿದ್ರೆ ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಅಲ್ಲ, ಅದಕ್ಕೆ ನಾನೇನು ಮಾಡ್ತೀನಿ, ಐ ರೈಟ್ ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಆಕ್ಚುಲಿ ಇದು ಚೇಂಜ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. Change in kinetic energy is final kinetic energy minus initial kinetic energy. ನಾನು ಯಾಕೆ ಬರೀ ಹಾಫ್ ಎಮ್ ವಿ ಸ್ಕ್ವೇರ್ ಬರ್ದೀನಿ ಹೇಳ್ರಿ? ಫೈನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅಷ್ಟೇ ಬರ್ದೀನಿ, ಯಾಕೆ ಹೇಳ್ರಿ? ಮೈನಸ್ ಇನಿಷಿಯಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಬರೀಲಿಲ್ಲ. ವರ್ಕ್ ಡನ್ is actually change in kinetic energy. I have just written final kinetic energy, half mv square. I have not written initial kinetic energy. Why? ಯಾಕೆ? Because it is zero. Initial kinetic energy illa, particle is initially at rest. So half mv square is equals to EV. ನಮಗೆ ಕೇಳಿದ್ರೆ final velocity. We are asked to find final velocity. This is final velocity, v square. So v square is equals to 2ev by m ಆಗ್ತದೆ. So v is equals to square root of 2ev by m. This is the final velocity of the charged particle. This is the final velocity of the charged particle. Option is C. Is this clear? Is this clear? How to solve problems on work energy theorem? You will be given work done. You will be asked to calculate either kinetic energy or you will be asked to calculate final velocity. Can you tell me what will be the change in kinetic energy of the charged particle? Can you tell me what will be the change in kinetic energy of the charged particle? An electron of mass m kg and charge E travels from rest through a potential difference of V volts. What is the change in kinetic energy? Final velocity bada. Just tell me what is change in kinetic energy. Just change in kinetic energy. What is the change in kinetic energy of the electron? Just tell me what is the change in kinetic energy. Change in kinetic energy is V minus 0. No? Change in kinetic energy. Read out the question. An electron of mass m kg and charge E travels through a potential difference of V volts. Charge kotare, potential difference kotare, charge on electron is given as E, potential difference is given as V, mass of electron is given as m. Tell me what is the kinetic energy, change in kinetic energy. Change in kinetic energy will be equal to work done, that is known from work energy theorem. Nanige tell me the value of change in kinetic energy in terms of m, E and V. ಈ ಮೂರು ಟರ್ಮ್ಸ್ ನಾಗೆ ಹಾಗನ ಒಂದು ಕಾಂಬಿನೇಷನ್ ಹೇಳ್ರಿ. ಎಂ ಇ ವಿ ಟರ್ಮ್ಸ್ ನಾಗ ನೀವು ಆನ್ಸರ್ ಬೇಕು. ಐ ವಾಂಟ್ ಚೇಂಜ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಎಂ, ಇ ಅಂಡ್ ವಿ. ವಾಟ್ ವಿಲ್ ಬಿ ದ ಚೇಂಜ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ? What will be the change in kinetic energy? I'll just show you this concept. Work done is equals to change in kinetic energy. Now tell me what will be the change in kinetic energy. Charge on electron is E, potential difference is V volts, mass of electron is m. Tell me what is the change in kinetic energy. Change in kinetic energy is equals to work done. Very good. V into E, potential difference is V and charge on electron is E. So work done is equals to potential difference into charge. Work done is nothing but change in kinetic energy. Potential difference is given as V and charge on electron is given as E. So change in kinetic energy will be equal to E into V. This will be the change in kinetic energy. Work done ne kinetic energy ಆಗಿರ್ತದೆ. ಆ work done ಎಷ್ಟು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಹೇಳಬೇಕು ನೀವು. Work done will be potential difference into charge. Or will clear and mention ಮಾಡ್ತಿದ್ದಾರೆ potential difference is V volts, charge on electron is E. So change in kinetic energy will be E into V or V into E, whatever. So this is problem on work energy theorem. ಈ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ರಿ. ಇದಾದ್ಮೇಲೆ you may be given coordinates of position. ಡೈರೆಕ್ಟ್ ಆಗಿ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಟೂ ಚಾರ್ಜಸ್ ಕೊಡ್ದಂಗೆ you may be given the coordinates of position of the charges. ಈ ರೀತಿ -9 cm, 0, 0, 9 cm, 0, 0 ಈ ರೀತಿ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಕೊಟ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳ್ತಾರೆ. ಈ ಪ್ರಾಬ್ಲಮ್ ನೋಡ್ರಿ ಹೇಗದೆ. ಎ ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್ 7 microcoulomb and minus 2 microcoulomb are placed at minus 9 centimeter, 0, 0, 9 centimeter, 0, 0, respectively. Electrostatic potential energy of the system is. See here the position coordinates are given. You are not given the distance between two charges. It is said that there are two charges, 7 microcoulomb and minus 2 microcoulomb. 7 microcoulomb is placed at minus 9 centimeter, 0, 0. Minus 2 microcoulomb is placed at 9, 0, 0 centimeter. You need to find out electrostatic potential energy of the system. Can you tell me what is the distance between 7 microcoulomb and minus 2 microcoulomb? E coordinates nodi, can you tell me what is the distance between 7 microcoulomb and minus 2 microcoulomb charge? Two charges, 7 microcoulomb and minus 2 microcoulomb are placed at minus 9 centimeter, 0, 0, 9 centimeter, 0, 0. You need to calculate electrostatic potential energy of the system of charges. Can you tell me what is the distance between the two charges? Coordinates ನೋಡಿ ಹೇಳ್ತೀರಾ? ಎರಡು ಚಾರ್ಜ್ ಮಧ್ಯೆ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿದೆ ಅಂತ? Very good, 18 centimeters. That is shown here. ಇಲ್ಲಿ ತೋರಿಸಿ ನೋಡ್ರಿ. This is Cartesian coordinate system. This is positive x-axis. This is negative x-axis. Positive y, negative y-axis. Charge 7 microcoulomb is placed at minus 9, 0, 0. Andre negative x-axis ಮೇಲೆ 7 microcoulomb place ಮಾಡಾರೆ. Minus 2 microcoulomb is placed on positive x-axis at 9, 0, 0. ಈ ಎರಡು ಚಾರ್ಜಸ್ ಮಧ್ಯೆ ಡಿಸ್ಟೆನ್ಸ್ ಮೆಜರ್ ಮಾಡಿದ್ರೆ ಈ ಕಡೆಗಿಂದ ಡಿಸ್ಟೆನ್ಸ್ ಮೆಜರ್ ಮಾಡಬೇಕು. ಈ ಕಡೆಗಿಂದ 9 ಸೆಂಟಿಮೀಟರ್, ಈ ಕಡೆಗಿಂದ 9 ಸೆಂಟಿಮೀಟರ್. Distance cannot be negative. Sir, ಈ ಕಡೆಗೆ minus 9 centimeter ಆಗ್ತದಲ್ಲ. We are measuring distance between the two charges. Distance cannot be negative. So origin ಇಂದ ಈ ಕಡೆಗೆ 9 centimeter. ಈ origin ಇಂದ ಈ ಕಡೆಗೆ 9 centimeter. 9 plus 9, 18 centimeter. So ಇವೆರಡು charges ಮಧ್ಯೆ 18 centimeter distance ಇರ್ತದೆ. So R is 18 centimeter. Potential energy of system of two charges can be calculated using this formula. 1 by 4 pi epsilon Q1 Q2 divided by R. Can you tell me potential energy of this system comes out to be positive or negative? ಈ ಸಿಸ್ಟಮ್ದು potential energy positive ಬರ್ತದ ನೆಗೆಟಿವ್ ಬರ್ತದ ಹೇಳ್ರಿ? ಈ ಸಿಸ್ಟಮ್ದು potential energy positive ಬರ್ತದ ನೆಗೆಟಿವ್ ಬರ್ತದ? ಆಪ್ಷನ್ಸ್ ನೀವು ಆಮೇಲೆ ಮಾಡ್ರಿ, ಇವಾಲ್ಯೂಯೇಷನ್ ಮಾಡ್ರಿ ನೀವು ಆಮೇಲೆ. Can calculate 1 by 4 pi epsilon Q1 Q2 divided by R ಮಾಡಿದ್ರೆ you will get the answer. Just tell me whether the potential energy of this system will be positive or negative. Potential energy of this system should be negative. I have told you, while calculating potential energy of system of charges, you need to take into account the sign of the charge also. Q1 is positive and Q2 is negative. 7 into minus 2 ne ಮಾಡಬೇಕು, minus 14. So potential energy will come out to be negative. ಇವೆರಡರಾಗ ಯಾವುದೋ ಒಂದು ಆಪ್ಷನ್ ಬರ್ತದೆ. B and D. ಇವೆರಡರಾಗ ಯಾವುದೋ ಒಂದು ಆಪ್ಷನ್ ಬರಬೇಕು. So evaluate it. Potential energy of this system should be negative. Negative potential energy indicates that these two charges form a bound system. Positive and negative charges will be bounded or will be held together by electrostatic force of attraction. ಇವೆರಡರ ಮಧ್ಯ electrostatic force of attraction ಇರ್ತದೆ. So you try to evaluate this problem. ಇದಾದ್ಮೇಲೆ there is another standard problem. This is a standard problem. This is again problem on relationship between electric field and electric potential. E is equals to minus dV by dx. Relationship between electric field and electric potential mal problem ada. Electric potential at a point in free space due to a charge q coulomb. Electric potential at a point in free space due to a charge q coulomb is q into 10 to the power of 11 volts. One point hatra q coulomb charge in the electric potential ಕೊಟ್ಬಿಟ್ಟಾರೆ. Electric potential at a point due to a charge of q coulomb is q into 10 to the power of 11 volts. Electric field at that point is, you need to find out electric field at that point. Options nodri, 12 pi epsilon naught q into 10 power 12, 10 power 22, 4 pi epsilon naught q into 10 power 22, 12 pi epsilon naught q into 10 power. ಅಂದ್ರೆ ನಮಗೆ options are required in terms of pi epsilon naught. Options are required in terms of pi epsilon naught. What is given to us is potential at a point is given as q into 10 power 11 volts. There is a source charge q coulomb. ಈ source charge q coulomb ಎಷ್ಟು potential produce ಮಾಡಿದೆ ಅಂತಂದ್ರೆ q into 10 power 11 volts ಅಷ್ಟು potential create ಮಾಡಿದೆ. We are given potential at a point. You are asked to find electric field at that point. We know that the relationship between electric field and electric potential is E is equals to minus dV by dx. This equation should be used only when V is given as function of distance. ಈ equation ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ when V is given as function of distance. V is equals to 4x square. Find electric field at 1, 2, 2 ಅಂತ ಕೊಟ್ರೆ differentiation of 4x square with respect to dx 8x ಬರ್ತದೆ minus 8x minus sign ಯೂಸ್ ಮಾಡಬೇಕು. But when you are given potential at a point and you are asked to find electric field at that point, at a point potential is given, you are asked to find electric field. Avaga electric equation ee riti barkobeku. E is equals to V by R anta baribeku. We have to write E is equals to minus dV by dx as E is equals to V by R. Idu hage bantu nodri. We know electric field due to a point charge is given by electric field 1 by 4 pi epsilon q by R square barbekala. 1 by 4 pi epsilon q by R square. I'll write R square as R into R. I'll write R square as R into R. Can you tell me what is this 1 by 4 pi epsilon naught q by R? Idishte ಏನು ಹೇಳ್ತೀರಾ? E is equals to what is 1 by 4 pi epsilon naught q by R? What is 1 by 4 pi epsilon naught q by R? 1 by 4 pi epsilon naught q by R is V divided by idishtun V anta bardini divided by R ada. So E can be expressed as V by R. When you are given potential, you can calculate electric field. ಇದನ್ನು ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ only when potential is given as function of distance. V is equals to 4x square plus 3y ಹೀಗೆ ಕೊಟ್ಟಾಗ E is equals to minus dV by dx ಯೂಸ್ ಮಾಡ್ರಿ. When you are given potential at a point and if you are asked to find out electric field, use E is equals to V by R. Electric field is equals to electric potential divided by distance. Right? ಈಗ ಹಾಗಾದ್ರೆ ನೋಡ್ರಿ ನಮಗೆ we know that V is equals to 1 by 4 pi epsilon q by R. What is potential at a point due to charge q coulomb given as potential at a point is given as q into 10 to the power of 11 volts, that is equals to 1 by 4 pi epsilon q by R. Q and q gets cancels. ನಾನು ಯಾಕೆ potential equation ಬರ್ದಿನಿ ಫಸ್ಟ್ ಗೆ ಅಂತಂದ್ರೆ we are given what is potential at a point. q into 10 power 11 volts ಅಂತ ಅವರೇ ಕೊಟ್ಬಿಟ್ಟಾರೆ ಪ್ರಾಬ್ಲಮ್ ನಾಗೆ. Potential at a point due to charge of capital Q coulomb is q into 10 power 11 volts. Potential ಕೊಟ್ಟಾರಲ್ಲ, so I'll write the equation for potential. V is equals to 1 by 4 pi epsilon naught q by R. I know what is the value of potential, q into 10 power 11, that is equals to 1 by 4 pi epsilon naught q by R. Q and q gets cancelled out, so I'll be left out with 1 by R is equals to ಈ 4 pi epsilon ಈ ಕಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬಿಟ್ರೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಡ್ರಿ 1 by 4 pi epsilon 9 into 10 power 9 ಅಂತ. ಯಾಕಂದ್ರೆ ಆಪ್ಷನ್ಸ್ ಆರ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ pi epsilon naught. If you substitute 1 by 4 pi epsilon naught as 9 into 10 power 9, you will be losing 1 by 4 pi epsilon naught, or you will be losing the term pi epsilon naught. ಈ ಟರ್ಮ್ಸ್ ಹೋಗ್ಬಿಡ್ತಾವ, ಅದನ್ನ ರಿಟೈನ್ ಮಾಡಬೇಕು. ಆಪ್ಷನ್ ಆರ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ pi epsilon naught. ಅದಕ್ಕೆ ನಮಗೆ ಆಪ್ಷನ್ಸ್ ಕೂಡ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗ್ತವೆ. ನಮಗೆ ಏನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅದನ್ನ ನೋಡ್ಕೋಬೇಕು ಆಪ್ಷನ್ ನಾಗೆ, ಅದೇ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. So I'll retain this 4 pi epsilon naught as it is. Q and Q gets cancelled out. So 1 by R can be written as, if 4 pi epsilon naught ikade multiply ಮಾಡ್ಬಿಡ್ರಿ, 1 by R will be 4 pi epsilon naught into 10 power 11. I got to know what is 1 by R. I got to know what is 1 by R. I was asked to find what is electric field. We know that E is equals to V by R. I know what is V. Potential ಎಷ್ಟಂತವರೆ ಕೊಟ್ಬಿಟ್ಟಾರೆ. Potential is Q into 10 power 11 into 1 by R. V by R can be written as V into 1 by R. V is Q into 10 power 11 into, I have calculated what is 1 by R. 1 by R is 4 pi epsilon naught into 10 power 11. So E is equals to 4 pi epsilon naught Q 10 power 11 into 10 power 11 should be 10 power 22. ಇದೊಂದು ಸ್ವಲ್ಪ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ರಿ. This must be 10 power 22. 10 power 11 into 10 power 11 is 10 power 22. So arriving at the desired result is most important. ನನಗೆ ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಕೊಟ್ಟಾರೆ ಅಂತ ಗೊತ್ತಾದ ತಕ್ಷಣ ಪೊಟೆನ್ಷಿಯಲ್ ಫಾರ್ಮುಲಾ ಬರ್ಕೋತೀನಿ. Potential is due to charge capital Q. So V is equals to 1 by 4 pi epsilon naught capital Q by R. I am asked to find electric field. I know what is electric field in terms of electric potential. E is equals to V by R. ನನಗೆ V ಗೊತ್ತು, R ಗೊತ್ತಿಲ್ಲ. ಹಾಗಾಗಿ ನಾನು R ಏನು ಅಂತ ಡಿಟರ್ಮೈನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೀನಿ ಯಾವಾಗಲೂ. I want to find what is R because I already know what is V. Potential is Q into 10 power 11 volts. Or a problem not potential is Q into 10 power 11 volts. So I know what is V. I want to know what is R. So what I did is I wrote the formula for potential. V is equals to 1 by 4 pi epsilon Q by R. V is Q into 10 power 11. That is equals to 1 by 4 pi epsilon Q by R. Q and Q gets cancelled. I do not substitute for 1 by 4 pi epsilon because options are in terms of pi epsilon naught. So I return it as it is. I'll get to know what is 1 by r. 1 by r will be equal to 4 pi epsilon naught into 10 power 11. E is equals to V by r. Okay? V is Q into 10 to the power of 11. 1 by r is 4 pi epsilon naught into 10 power 11. 10 power 11 into 10 power 11 should be 10 power 22. Idaste correction ಮಾಡ್ಕೊಳ್ರಿ. This must be 10 power 22. 4 pi epsilon naught Q into 10 to the power of 22 volt per meter. Electric field can also be expressed in volt per meter. See, E is equals to V by R. V is potential expressed in volts. R is distance expressed in meter. Newton per coulomb is also the SI unit of electric field. Volt per meter nu baribodu. Newton per coulomb antanu baribodu. Force experienced by unit positive test charge is electric field. Potential drop per unit distance, V by R, potential difference per unit distance is electric. So this is regarding the problem on relationship between electric field and electric potential. ಈ equation ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ potential ಕೊಟ್ಟು electric field ಕಂಡುಹಿಡಿಯಿರಿ. potential value ಕೊಟ್ಟಿರ್ತಾರೆ Q into 10 power 11, 10 into 10 power 2 ಈ ರೀತಿ potential value ಕೊಟ್ಟು electric field find out ಮಾಡ್ರಿ ಅಂದ್ರೆ E is equals to V by R ಯೂಸ್ ಮಾಡ್ರಿ. Differentiate ಯಾವಾಗ ಮಾಡಬೇಕು only when V is given as function of distance. V is equals to 3x square plus 2x ಕೊಟ್ಟಾಗ E is equals to minus dV by dx ಯೂಸ್ ಮಾಡಿ. ಯಾವಾಗ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಯೂಸ್ ಮಾಡಬೇಕು ಯಾವಾಗ E is equals to V by R ಯೂಸ್ ಮಾಡಬೇಕು ಗೊತ್ತಿರಬೇಕು. Right? Are these problems clear? These are some of the important type of problems from potential. I have solved all the important type of problems from electric potential. Different possibilities are explored. ಯಾವ್ಯಾವ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರ್ಬೋದು ಅದೆಲ್ಲದನ್ನು ಇಲ್ಲಿ ತಗೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿದೆ. Are this clear? ಯಾವ್ದನ್ನ ಕಾನ್ಸೆಪ್ಟ್ ಡೌಟ್ ಅದ? ವಾಟ್ ಈಸ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇಸ್ ಯು ನೀಡ್ ಟು ರಿಮೆಂಬರ್ ದ ಫಾರ್ಮುಲೆ. ಫಾರ್ಮುಲೆ ಗೊತ್ತಿಲ್ಲ, ಯಾವ ಫಾರ್ಮುಲೆ ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಗೊತ್ತಿಲ್ಲ ಅಂತಂದ್ರೆ ಕಷ್ಟ ಆಗ್ತದೆ. ಅಂಡ್ ದಟ್ ಕಮ್ಸ್ ಬೈ ಪ್ರಾಕ್ಟೀಸ್. If you do not read the notes, if you do not solve the problems, you will not get to know how to solve a problem. What formula is to be used for the given problem, that will not be known. Are this clear? If these are clear, we'll start atoms from tomorrow. Atoms. Is it clear of the problem? So do not worry, after coming back to college, ಉಳಿದಿರೋ ಚಾಪ್ಟರ್ಸ್ ಆದ್ಮೇಲೆ ಇದ್ರ ಮತ್ತೆ ನಾನು ರಿವಿಷನ್ ಮಾಡ್ತೀನಿ. ಐ ವಿಲ್ ಟೇಕ್ ಅಪ್ ದ ರಿವಿಷನ್ ಆಫ್ ದಿಸ್ ಚಾಪ್ಟರ್ಸ್ ಆಸ್ ವೆಲ್. ಇನ್ನೊಂದು ಸಾರಿ CET ಕೂಡ ಈಗ ಉಳಿದಿರೋ ಚಾಪ್ಟರ್ಸ್ ಫಸ್ಟ್ ಮುಗಿಸಿ ನೀವು ಕಾಲೇಜಿಗೆ ಬಂದಾದ್ಮೇಲೆ ಐ ವಿಲ್ again go back to these chapters and revise this again. Okay then, we'll continue in the next class.